Alright, let's take a look at the binomial probability theorem. So what this says is, we're going to find the probability of getting exactly k successes in n trials of doing something. So if we get k successes, that means we must get n minus k failures. So that's something to keep in mind, because you have to account for everything that happens. And the probability of success, we're going to call p. And if p is the probability of success, that means that 1 minus p must be the probability of failure. So again, we want to account for everything. So k successes means n minus k failures. Probability of success is p, means that the probability of failure is 1 minus p. Alright, so the probability of exactly k successes in n trials is going to be given by n choose k. So you might not be familiar with that notation. We'll deal with that in a second. And then that's going to be multiplied by, so it's p, the probability of success, raised to the k, because p has to happen k times, and we're going to multiply them, so p to the k. And then we have to account for everything. So the probability of failure was 1 minus p, and that has to happen n minus k times. So we multiply all that together, and that's going to give us our probability of exactly k successes in n trials. So this notation that I use is n choose k. So you might be more familiar with the second notation there, the nck. You actually are probably more familiar with ncr, because that's what calculators call it. If you use a TI Inspire, the way you get it on a calculator page is menu 5.3, or you can just type in ncr, and it'll look like this. So that's how the calculator does 3 choose 2, for example. Alright, let's do an example. So if we flip a fair coin 3 times, so this actually, it's not so bad to write out the entire sample space. So on the first flip, we could get heads or tails. And then if we got heads the first time, we could get heads or tails the second time. And the same thing is true if we got tails the first time. So heads or tails comes off of each of them, kind of branching. And then for each thing that happened on the second level, heads or tails could happen again. So we end up with this. So across the board, heads or tails. Okay, so now we can answer some questions, and you can kind of count from the tree, so we'll know if this theorem is working for us, which it is, but let's see. So the first question, probability of exactly 1 heads after doing 3 flips of a coin. So if you look at the trees, or this tree diagram, you can just kind of count them. So you could get heads, tails, tails. You could get tails, heads, tails, or tails, tails, heads. So check, check, check. So any of those 3, and there are 8 total things that could have happened. So it's 3 out of 8. Let's see how the theorem gives us that. So it's 3 choose 1, 1/2 to the first, and then 1/2 to the 3 minus 1. So this is because it's a fair coin. So that's going to, when we punch it in, give us 3/8, so it's working. What if we wanted the probability that we get all heads? Well, you can actually just see that the only way that's going to happen, some bad erasing right there, get out of there. The only way that that happens is if that first branch, so you go heads, heads, heads. So that's going to be 1 out of 8, definitely. And the theorem says that's going to be 3 choose 3, and then 1/2 to the third, and 1/2 to the 3 minus 3, which is 1/2 to the 0. Punch that in, and you do in fact get 1/8. So it's working. Let's take a look at another problem. So say we have a 10-question multiple choice test with 4 choices per question, and we're going to randomly guess, so this is not a good strategy. What's the probability of getting at most 2 questions right? Well, at most is really important there, because that means we could get 0 questions right, we could get 1 question right, or we could get 2 questions right, but we can't get 3 because that's more than 2, so that wouldn't be at most 2. So that's an important distinction. So in this problem, n is 10, k is going to be, we could get none right, we could get 1 right, or we could get 2 right. So we're going to have to do each of those, and then we're just going to add our answers together. The probability of success is 1 in 4 because there are 4 choices per question, which means the probability of failure is 3/4, 3/4, or 1 minus 1/4. So if we get none of them right, we're going to do this. So 10 choose 0, 1/4 to the 0, because it doesn't happen, and then 3/4 to the 10 minus 0, or 10 times we failed. So that's getting none right. then we get 1 right, or exactly 1 right. So it just works out again. And then if we get exactly 2 right, we would get this, according to the theorem. I punched this into my calculator, and it gave me approximately 0.526. So we have a better than 1/2 chance of getting at most 2 right, so this strategy is awful. There's kind of a similar question we could have asked, and that's the probability of getting at least 3 questions right. Well, if you think about it, these are complementary events, so that's just 1 minus the probability of at most 2, because either you get 0, 1, or 2, which is at most 2, or you get some other number, which would be at least 3, so 3 through 10. So in that case, the probability of getting at least 3 right is 0.474, which is not a very good probability. So I do want to just take 1 second and talk about that. So at most k means that you get 0, 1, all the way up to k. At least k would mean that you go, k is the minimum you can get, and you could go all the way up to n, so the total number. And if you want to look at that kind of in a picture, so let's say we have 10 things, and this right here is at least 3, and calculating that would be a giant pain in the neck, but if you look at the part I didn't box, it's much easier to calculate. So instead of calculating at least 3, what I would do is I would calculate at most 2. That's supposed to say easier. I don't even know. That says like easier. That's easier to calculate, so that's what I would do. And that's kind of how you end up using the theorem, because you don't want to do, why do all of those calculations when you could just do 3? But anyway, I hope you found this helpful, and good luck with that.